So, in this video, the data mining, knowledge discovery process, and kinds of data meant for mining and kinds of patterns that can be mined will be discussed. Why data mining is needed, the explosive growth of data from terabytes to petabytes, data collection and data availability, automated data collection tools, database systems, web and computerized society. Major source for abundant data, business, science, society and everyone. We are drowning in data but saving up for knowledge. The necessity is the mother of invention. Data mining is an automated analysis of massive data sets. What is data mining? Extraction of interesting patterns or knowledge from huge amount of data. The alternative names for this one: knowledge discovery in databases, knowledge extraction, data analysis, data archaeology, data dredging to find patterns, information harvesting, business intelligence, and so on. Many people treat data mining as a synonym for another popularly used term, knowledge discovery from data, or KDD, while others view data mining as merely an essential step in the process of knowledge discovery. The knowledge discovery process is the number one: data cleaning, data integration, data selection, data transformation, data mining, pattern evaluation, and knowledge representation. Data cleaning means removing noise and inconsistent data. Data integration is multiple data sources may be combined together. Data selection, data relevant to the analysis task are retrieved from the databases. Data transformation is data transformed or consolidated into forms of appropriate for mining. Data mining, an essential process where intelligent methods are applied. Pattern evaluation, identify the truly interesting patterns. Knowledge presentation is mined knowledge is presented to the user with visualization or representation techniques. In general, data mining can be applied to any kind of data as long as the data are meaningful for a target application. Most basic forms of data mining applications are database data, or data warehouse data, and transaction data. The concepts and techniques presented here is nearly data related. Data mining can also be applied to other forms of data like data streams, ordered or sequence data, graph, network data, spatial data, text data, multimedia data, and so on. We can give an overview about these techniques for mining these kinds of data, then how depth it is applied in the data mining applications. Data mining will continue as an important one in the new data types as they emerge. A database system, also called a database management system, consists of a collection of interrelated data known as a database and a set of software programs to manage and access the data. A relational database is a collection of tables, each of which is assigned a unique name. Each table consists of a set of attributes, columns or field names, and usually stores a large set of tuples known as records or rows. Each tuple in a relational table presents an object identified by unique key prescribed by a set of attribute values. A semantic data model, such as an entity relationship data model, is often constructed for relational databases. An ER data model represents the database as a set of entities and their relationship. Data warehouse is a repository of information collected from multiple sources, stored under a unified schema, and usually residing at a single site. Data warehouses are constructed through a process of data cleaning, data integration, data transformation, data loading, and periodic data refreshing. This is described in this chapter. Each record in a transaction database captures a transaction such as a customer's purchase, a flight booking, or a user's clicks on a web page. A transaction typically includes a unique transaction identified number and a list of items making up the transaction, such as the item purchased in the transaction. A transactional database may have additional tables which contain other information related to the transaction, such as item description, information about the salesperson or the branch, and so on. Object relation databases. Object relation databases are constructed based on an object relation data model. This model extends the relation model by providing a rich data type for handling complex objects and object orientation. Objects that share a common set of properties can be grouped into an object class, a set of variables that describe the object, a set of messages that the object can use to communicate with other objects, a set of methods where each method holds the code to implement a message. Temporal database stores relational data that include time-related attributes. A sequence database stores sequence of ordered events with or without a concrete notion of time. Example, the customer's shopping sequences. A time series database stores sequences of values or events obtained over repeated measurements of time. Example, data collected from the stock exchange or the inventory. Spatial databases contain spatial related information. Example, geographic databases commonly used in vehicle navigation and dispatching systems. A spatial database that stores spatial objects that change with time is called a spatio-temporal database. The text databases are databases that contain word descriptions for objects. Example, product specification, error or bug reports, warning messages, etc. Multimedia databases store image, audio, and video data. They are used in applications such as picture content-based retrieval, voicemail systems, video on-demand systems, etc. Heterogeneous databases and legacy databases. Heterogeneous database consists of a set of interconnected autonomous component databases. A legacy database is a group of heterogeneous databases that combines different kinds of data systems. Applications involve the generation analysis of new kind of data called stream data, where the data flow in and out of an observation platform dynamically. The features of data streams are the huge or possibly infinite volume, dynamically changing data, flowing in and out in a fixed order, allowing only one or small number of scans, demanding fast. Training can help us learn about the distribution of information on the www in general, characterize and classify web pages, and uncover the web dynamics and the association and other relationships among different web pages, users, communities, and web-based services.